Okay, so this video is meant for my geometry students. We do have a quiz covering sections 8.1 through 8.3 coming up on Tuesday or Wednesday. This is the last major grade of the quarter, so it's very important we do well. Your note cards are very important in this quiz, so make sure you have those note cards memorized, right? Pythagorean theorem, special right triangles, and trigonometry. Now, you're going to have all kinds of right triangles on this quiz, and the idea is, can you identify how to approach the problem correctly? Alright, so let's start with this first problem. It says, find the value of x, and here's your picture. Now, this is a right triangle, and they gave me two of the three sides. This is Pythagorean theorem. A squared plus b squared equals c squared. In this picture, your c is your hypotenuse, that is x. Then 7 and 24 are a and b. It doesn't matter which one is which. And we plug it in. So a is 24 in my problem, b is 7 in my problem, and c is x squared. Okay, we use our handy-dandy calculator to get what 24 squared plus 7 squared is. And we see it as 625. And now we take the square roots. And we need to write them in simplified radical form unless it comes out to be a perfect square. So check first. And in fact, 625 is a perfect square. It's 25. And that is what x is. So check to see if it's a perfect square. If not, break it down, pull out the perfect squares, and go from there. Okay, problem 2, home maintenance. It says a painter leans a 15-foot ladder against the house. The base of the ladder is 5 feet from the house to the nearest tenth of a foot. How high on the house does the ladder reach? Okay, well, here is my house. I'll make a better house than that. Here's my house. And then I have a ladder right here. That's my ladder. So my ladder is 15 feet long. And here's the ground. And the ladder, the base of the ladder, so down here is 5 feet from the house. So this right here is 5 feet. Where the house meets the ground is a right angle, and there's my right triangle. And the question is, to the nearest tenth, how high up the house does the ladder reach? So what is that? Call it x. Again, right triangle, no angles given, two of the three sides, Pythagorean theorem. Okay? A squared plus b squared equals c squared. The hypotenuse is c, that's 15. A and b don't matter, so let a be 5, b be x. So a is 5, 5 squared, plus b is x, x squared equals c squared, 15 squared. 15 squared is 25, x squared is x squared, 15 squared is 225. Subtract 25 from both sides to get x squared alone. X squared is 200, and then take the square root. And we're going to round to the nearest tenth of a foot, so that gives me an x value of 14.1, and that is in feet. And that is how high the ladder reaches up the house, 14.1 feet. Alright, this problem, we are going to take the three sides of a triangle and determine whether the triangle is acute, right, or obtuse. Now, in this situation, we still use Pythagorean theorem, but I'm going to rewrite it with the c first. C squared, and I'm going to do it over here. C squared, I'm going to put a question mark. What is it compared to a squared plus b squared? Okay? Because c determines whether it's obtuse or acute, the value of c compared to the other two. Well, in this set of numbers, the bigger number is c. So 15 is c. The other two numbers, it doesn't matter. 11 squared plus 12 squared. Okay, so we know 15 squared is 225. We did it in the last problem. 11 squared plus 12 squared is 265. So now we fill in the inequality. 225 is less than 265. So if they were equal, it would be a right triangle. But now, the third side is smaller than the other two sides compared. So think of acute or obtuse. Which one's bigger? Obtuse is bigger, so since this side, the third side, is smaller, we're going with acute. And again, that's why I would put the C first, so you can really just follow that symbol. C being less than a squared plus b squared gives you acute. Okay, we have a couple problems coming up where we're going to find the value of each variable, so there'll be multiple variables. In this picture, we have a 45-degree angle and a 90-degree angle. So here they start giving us angle measures. Well, this is a 45, 45, 90 triangle. And in a 45, 45, 90 triangle, there's special relationships. The two legs are S, and the hypotenuse is S radical 2. So in this problem, they give you the hypotenuse of S radical 2. It's 15 radical 2. You need to find x, which is just S. Well, x is the S radical 2 without the radical 2. So I take my S radical 2, which is 15 radical 2, and I want to get just S. Well, to get rid of the radical 2, I divide, and that's exactly what I do here. And in this problem, the radical 2's cancel, and there's my x. X is 15. The y is the same as x. So now that I found x, I also know that y is 15. 45, 45, 90 triangle. Okay, problem B. Here we go. So I have a right triangle. I'm given a 60-degree angle, so I know that this is 30 degrees. Now this makes it a 30, 60, 90 triangle. We have labels for these sides. The hypotenuse, which is across from the right angle, y, is 2s. The short side across from the 30 is just s, and the long side is s radical 3. So if I'm trying to find x and y, in the 30, 60, 90, you always find the short side first. So we're going to find x first. X is just s. They give us what s radical 3 is. It's 9 radical 3. So to go from s radical 3 to s, I'm going to take what s radical 3 is, but then I'm going to get rid of the radical 3 by dividing by it. Here, the radical 3's cancel. I get an x value of 9. So x is 9, and then I look to find y. Y is 2 times s. That would be 2 times 9. Y is 18. And there's the 30, 60, 90 triangle. Okay, now let's take a look at this problem. We have a triangle, and notice in the triangle we have a 60-degree angle and a 45-degree angle. So what this means is, right here, in this left triangle, this is also a right angle, and this right here, this small angle is 30 degrees. We have a 30, 60, 90 triangle right there. On the right side, we have a right angle, 45. This is also 45. We have a 45, 45, 90 right triangle there. So we have two special triangles in one. Now, if I look at the two triangles, in this 30, 60, 90, I know one length. That's good. In the 45, 45, 90, I know no lengths. That's bad. We can't start there. We have to start with this triangle on the left, the 30, 60, 90. So I'll draw it out here. 4 radical 3, A, C. This is 60 degrees. This is 30 degrees. Okay, in the triangle there are labels. This is a 30, 60, 90 triangle. Let me put the right angle there. The hypotenuse is 2s. The short side is s, and the long leg is s radical 3. You need to find the short side first, if it's not given, the short leg. Well, they give me the hypotenuse, 4 radical 3. To find C, which is the short leg, I need S. Well, 4 radical 3 is 2S. So to go from 2S to S, I divide by 2. So take your 4 radical 3 and divide by 2. The 4 and the 2 will cancel, and C is 2 radical 3. And there's C. I'm going to actually put that on my picture. And I'll put it here too. 2 radical 3. Now to find A, do it right here. A is S radical 3. Well, I know what S is. Okay, I apologize. So whatever I was saying, we want to find A, which is S radical 3. We have S right now. It's 2 radical 3. So to find A, we're taking the S, which is 2 radical 3. That's S. And then I have to multiply it by another radical 3. Well, this becomes 2 times radical 3 squared. The 3 is now squared inside the square root, so the 3 comes out. And the square root's gone, and A is 2 times 3, which is 6. And I will put that on my picture. A is 6. So now I'm going to take the triangle on the right, this 45, 45, 90 triangle. I know that this is 6, this is D, and this is B, and now I'm going to find D and B. Now there are labels here as well. The sides, the legs are S, and the hypotenuse is S radical 2. So I would like to find the other leg first because I know what S is. So to find D, it's just the same as S, 6. And now to find the hypotenuse B, it's just S radical 2. Well, S is 6. 6 times radical 2. And there's how you do this complex problem here with 2 special right triangles in one. Alright, this problem says you have Jefferson Park, which sits on one square block, 300 feet on each side. Sidewalks across the park join opposite corners. So the nearest foot, how long is each diagonal sidewalk? Well, we need to start with a square here. Right, this is the block. And there are 300 feet on each side of this block. Now this block is a square, so we have right angles in all the corners. And now, these sidewalks are diagonals through the square. So diagonal, here's the sidewalk. I don't know what this is, so call it X. But I do know that it breaks these corner angles into 45 degrees. And now I have a 45, 45, 90 triangle. The labels on this triangle, again, are S, S, and the diagonal, the hypotenuse, is S radical 2. So I would like to find that diagonal X. It is S radical 2. I know what S is. S is 300. 300 times the square root of 2. And I just multiply. 300 square root of 2. And I get 4, what do they want? To the nearest foot. So no decimals, 424. And that is in feet. And there's the length of each sidewalk. Okay, problem 6 here. We are going to find the sine, cosine, and tangent of the picture here. And we're looking for angle M in this picture. So first thing we do is we identify the angle we're trying to find the trig ratios of, and that's M. So then we label the picture. Now the hypotenuse is always the hypotenuse. That's 9. The opposite side is a cross. It doesn't touch M. 7 and 9 touch M. 4 radical 2 does not. That's the opposite. And then the adjacent side is the third side. So to find the sine of M, we need to find the opposite over the hypotenuse. So the sine of M is equal to the opposite, 4 radical 2, over the hypotenuse, 9. If that fraction can simplify, simplify it. If not, you're done. There's the sine. The cosine of M is adjacent over hypotenuse. So the cosine of M in this case is adjacent, 7 over hypotenuse, 9. 7 over 9 does not simplify. You are done. And lastly, the tangent of M. The tangent of M, opposite over adjacent. So the tangent of M, opposite is 4 radical 2, adjacent is 7. If it simplifies, simplify. It does not. And there's the trig ratios for M in this right triangle. Okay, last two problems here. Find the value of X, round to the nearest tenth. Okay, so we take a look at this picture. So we identify the angle that they give us. They give us the 64-degree angle right here. So now we're going to use trig because 64 is not a special angle and we can't use Pythagorean theorem here, so we need to use trig. So 64 is here. The hypotenuse is right here. The opposite side doesn't touch 64. That's this X. The adjacent side is that 7 right there. Now, if I look at this picture, the opposite side's not marked. Don't use it. So we need to use the trig ratio that involves opposite and adjacent, and that is tangent. So we take the tangent of the angle 64 degrees. And over here I'll put tangent is opposite over adjacent. Right? Gotta have that memorized. So tangent of 64 degrees is opposite x over adjacent 7. Now, you want to solve this for x. There is a 7 in the denominator. Multiply both sides by 7. Remember, you take care of the denominator by multiplying by it. And we get over here 7 tangent of 64 degrees equals x. And now we just use our calculator. 7 tangent 64 degrees. And we get an x value rounded to the nearest tenth of 14.4. Okay, one more problem to go. Okay, so here we have another problem, and notice where x is. X is with the degrees. X is an angle. To find an angle, you must use inverse. Inverse finds the angle. Inverse. So we're going to use an inverse trig ratio here. Now, we identify the angle that we're focusing on. It's this x right here. The hypotenuse is always the hypotenuse. The opposite side is across from x. It doesn't touch the x. 13 and 9 touch the x. This side doesn't. So it's the opposite. And then the adjacent is the third side. So if I look, the opposite side doesn't matter here. So now the question is, which trig ratio involves adjacent and hypotenuse? And that is cosine. So cosine equals adjacent over hypotenuse. So we set up our equation. And our equation is the cosine of, now our angle is x, of x degrees, equals the adjacent side 9 over the hypotenuse 13. Now, to solve this, we need to use the inverse cosine. We take the inverse cosine of both sides. So we get x out, and now x is not the angle name, it's just a variable, so you can just x. And we get over here the inverse cosine of 9/13. This is how the x can come out, because we take the inverse cosine of both sides. And now we just type this in our calculator. Remember to press the second key first, second, and then cosine. And then it's just 9 divided by 13. And we get a value of x rounded to the nearest tenth of 46.2, and that is degrees, because it is an angle. And there we go. And there's the value of x. So inverses find angle measures. Remember that. Okay? So again, my advice, your 6 note cards, know them like the back of your hand. Very important. When do I use Pythagorean theorem? When do I use special right triangles? When do I use trig? Understand the different situations. Okay. Happy studying, and we'll see you on Tuesday or Wednesday.